Pepsi Max is better. And that'd be the first thing on the recording this time, then, I guess. Right, so where did we leave off last time? Let's just quickly go and take a look. Right, so we talked about that. We talked about that. Skip the array stuff. We've talked about this. We talked about 8.5. Right, so maybe it's just worth talking a little bit about code for field references. If I can get the pen to work, unless anybody has any questions. Coke Zero is not good. Anything Coke sucks. So this is Fig 8.6. So, for example, it's something that looks like that. As an example, we can use E.F or C.F, so class or expression. Now, if it's this guy, then we know that it's going to be a get static, because the modifier checker already checked that fields that are accessed through a class name are static. This one here could be a get static, but it could also be a get field. If we do this in order to get to a static field, then that expression there, which is going to be on the stack, is going to be a problem, because get static does not require a reference on the stack to an object, because it can be accessed that way. So we need to get rid of that one here. So we might want to say that we need to remove the target. So if we just, should we call that one number 1, number 2, and number 3? And we'll do some code here. And let's just do number 1, right? So what do we got? We got code for E. What does the stack look like at this point? It looks like that. And what do I got to do then? Well, we got to do a get field. Class C field F some type. And that's it, isn't it? And again, to get the code for E, that's just a simple visit to the target. Now, you might say, well, wait, if this, let's assume that this E here is of type C, just like that one. If that issues a get static, and get static does not require anything on top of the stack, then can't I just not ignore that thing there and just not even generate code for it? And the answer is no, you can't, because what if there was a side effect from evaluating that? Then that has to be captured. So we're still going to say code for E, and then we'll get rid of it by saying pop, and then we'll get static CFT. So that's number 2 and number 3. And number 3 is very easy because there's no target code that needs running. That's the name of the class. So this is just get static CF, or whatever type it is. So easy enough. I just want to say a few words about 872 binary expression. So let's just say if BE is a binary expression, BE dot type is its type. So for example, 3 plus 4.2. So the binary expression would be something like this, plus literal 3, literal 4.2. Now, of course, the type of this might be int, and the type of this is a double, then the overall type is double. So if that's the case, it makes more sense to try to do the arithmetic in the type of the overall expression. So if we're going to do that, then sort of a first attempt at doing this might be something where we say code for BE dot left code for BE dot right, and then we will issue a dadd. Now the problem is, if I look at this over here, then this would be an I const 3, this will be an LDC 4.2, and then we'll have a D add. That doesn't work, does it? Because that's an integer, that's a double, and we're doing a double add, and double add requires two doubles. So we're going to need to turn that into a double right there. So what I can do is I can do some data conversion here. So that part there is just gen dot data convert, and we need be dot left dot type, and we need be dot type. And data convert will say, hey, if they're the same type already, I'm not going to do anything. Otherwise, I'm going to issue the right instructions to do the conversion. That's data convert of be dot right dot type and be dot type. And of course, you have to do the same thing for invocations, right? So if you're trying to call f that takes in a double and you pass it an integer, those actual parameters need to be type converted to that of the equivalent formal parameters. Right. We have to talk a little bit about 0-1 jumping, and this is example 814 because that's what we're going to do anyway. So let's start with just an example. If I say while x is not equal to y, subtract 1 from x. So Boolean expressions always evaluate to 0 or 1. So if I try to sort of lay out what the code for So this should look like. Then we have a code for x not equal y. At this point here, we will have a stack with a 0 or a 1 on, because that's the Boolean value of either x is equal to y or x is not equal to y. And then I can say, let me just check what I want to jump on here. Yeah. If it's false, then the loop is done and we can sort of bail out. So if I say here, if EQ go to L1, and then let's put L1 down here. And then we're going to have we'll have code for x equals x minus 1 there. And then we're going to have to go back up again. So we shall say go to L0, and then we'll put L0 up there. So if you look at the amount of code that I have to generate locally for the while statement, that amounts to 2 labels, that test, and a goto at the very end. So that isn't really all that bad. But now let's take a look at the x minus y thing. So let's say that, or where should we put x at 1, y at 2? So we need something like I load, let's assume they're integers, I load 1, I load 2. And then we can say if underscore ICMP not equal, so that thing there is not equal, then go to L3. I think I screwed up my labels a little bit, but yeah, I did. Let me just fix those. I mean, these label names are of really no importance, but I might as well use the correct one so that nobody gets confused. So we'll call that one L1, and we'll call that one L2, L2, L1. There we go. So no L0. Anyways, so we'll go to L3. Now, what should happen if I go to L3? We jump if they're not equal. So if they're not equal, then they are true. So if I don't jump, it's because it's false. So if I don't jump, I can say I const 0. So this is false. And then we'll go to L4. Then we'll have L3 here and say I const 1. So that's true. And then we'll have L4 there. So this code goes there, and this is easy enough because that's just IINC 1 comma minus 1, I think. Or I load 1, I const 1, I sub, I store 1. Label 3. It's right there. So if I look at this over here, then this is basically BE dot left. This is BE dot right. That there is the operator. And then this here is sort of 0, 1 boilerplate. So it shouldn't be too complicated. How many lectures have we got left? Let's just take a quick look. 4. Okay, that's all right. So the stuff that has to do with, excuse me, perhaps I make the burp. That has to do with direct jumping, you can disregard because we're not going to do that. We're going to do this with all Boole expressions, whether they're in whiles, fors, do's, and whatnot. Generate a 0 or 1 on top of the stack. Now, can we just try some code here? Oh, my Pepsi out of the way so this doesn't end in a disaster. Right, so I'm going to go and say share content. I'll continue with this X8 thingy that, no, actually, I think I'm gonna call it X9 instead because that stuff was good stuff. And then I just have to remind myself what on earth it was that I want. Oh, I know what I wanted to do. Public class X9. Public static void main string. So int x, y, and z. X is 1, y is 0. If x is equal to 0 and x divided by y is less than 1, then z is equal to 9. What do you think of that code? Would you agree that it is semantically the same as that? So let's try that. Oops. Try that first. Wow, I think the Espresso compiler is on hiatus or something. What the hell's going on here? Is this like one of the bad compiles? Oh. Does ant work? There we go. Nothing happened, which is exactly what we expected, right? I suppose we could have tried to print it out, but that's okay. Nothing happening is good. So I would expect if this is equivalent, that nothing will continue to happen. And it did. Right, so that's fine. All right. Those are exactly the same. What does Shilly say? He says, would it cause error since x was 1 and y was 0? Well, x is not well, so if I do that, what happens now? Jonathan says, wouldn't cause an error because of short circuiting for the first one. I think that's what it's called. Well, so over here, now I would actually get an error here still, I think. I think this was a stupid example that I came up with here because it didn't let you do what I wanted it to do. So if I comment that out and I do that, and that, then I get a division by 0, right? And that's, of course, because that was true, and that's an AND. So we better continue on and check to see if this is true, and that causes a problem here. But when this was false to begin with, then it didn't really matter what this was because we never got around to evaluating it, right? So it is indeed short-circuit Boolean evaluation. Now, what here's something interesting. I'll print out y there. To do that, we need to import system. We can do that. So what will happen if I run that? Well, let's give it a go. We get division by 0. Okay, fine. Maybe we can avoid that by putting the pluses on the other side. Nope. Suggest that first. There we go. We get a 1. Okay, right. Great. Y is 1. So y gets incremented to 1 before we do this division, and everything's happy. Right. So if I change the value of x here now, oops, and compile, Jasmine, and run it, I get a 9. I get a 0. Okay, that's a little bit dangerous, isn't it? Just because this thing now has a different value. Before it was true, now it's false. That thing here never gets executed anymore. So we got to be a little careful. We got to be a little careful with the short-circuit Boolean evaluation, because if there's stuff that never gets executed because of short-circuit Boolean evaluation, it could be a little confusing. So in other words, you might not want to have things in expressions that can be short-circuited if they have side effects. Now let's just take a quick look at, let's just yank all that stuff out. So actually we can just, yeah, let's say z equals 4, like that. And then let's look at what the code we get is. And just clean it up a little bit. Hopefully we can get it onto the same screen. Very close. I think I can do it. So if we look at that, and actually just take that part and put there, and let's get rid of those 2 lines and those 2 lines and those lines, right? So this is the code that gets generated for this if statement. Now the most important one is this one here, and I think if we go down here, we can see that this line, so if we go down and we try to identify what's what, so this one here is x equals 4 along with, so that those two take care of that. This one here is part of the if statement. So this is if the expression in the if was false, and then we jump to here, right? So just like we've seen before, all this stuff here has to do with the actual if statement. So that means all this stuff up here has to do with the expression. So let's just put a line in here. Oops. There we go. Cool. Now let's see if we can figure out what's going on up here. So this maybe not in quite so capital letters. This is load x. This is push 0. So you can see that we're sort of working our way towards this thing over here, right? And now we should hopefully see something that does exactly what we expect. So it should be something that uses that thing here, jumps in exactly the same way as we did before. So if equal, go to L2. What happens at L2? Push 1, so that's the true part. And what happens here? Push 0, that's the false. And then jump around, and we're now down to here. So we definitely know that at this point right here, the value of x equals 0, which is either 0 or 1, is on the stack. Right, so what do I know about an AND? Well, I know that if the first one is false, then we might as well just leave. Then that means this entire thing is false. So because I need to leave a 0 or 1 on top of the stack, I'm going to duplicate it, because in this jump that comes after, that uses up one of the values. So I need to save it. If I didn't duplicate things here and I did this jump here, by the time I got down to here, I wouldn't have a 0 or 1 on top of the stack, which I must have. So what happened there? We can say if x equals 0 was false, then bail out. And bail out is down here, right? So if I hadn't had this last part, this would have been the end. That would have been right here. So if I took that part out, then that's the same as ripping out this stuff here, right? Now what do I do here? Do the same thing again. I duplicate. If I already have a false, then bail out. Now we're down here. So you can see if this thing here is false, then we go through evaluating this. We jump from here, and don't bother with that, down to here, jump from here to here, and this original 0 value that this evaluated to, because we assume it was false, would be on top of the stack. Now what happens if it were a 1? Well, we would duplicate, so we'd have 2 1s at the top of the stack here. We wouldn't jump because the top of the stack isn't equal to 0, and then we would get rid of it. So actually, let's well, no, I don't want to write that down. But so if it's a 1, then I have 2 1s here. That removes one of them. That removes the other one. Now, why am I throwing the other one away? Well, because if it's an AND, then if this is true, then the value of the AND expression is determined solely by the truth value of this guy. All right, so how do we calculate that? Well, that's the, now we come down to here, which is load y, push 0, if equal, go to L5, push 0, which is false, jump around, push 1, which is true. And the jump around was to L5, which is here. And the jump around was there to L6, which is there. Okay. That 4 came from up here. So that's if this happened to be false up here, then we would just jump over this because we would know we were done, right? So that second part stops here. Now, what's going to be on top of the stack at this point? Well, it's either going to be that 0 from up here if this were false, and if this were true, then the value was removed here, and the value that's going to be left on top of the stack is simply the value of y. So it's going to be the value of 0 if x equals 0 was true. Otherwise, the value of y equals 0. Now, if that evaluated to 1, I duplicate and I don't jump, so I pop that off, do the exact same thing here. So only if all of the previous ones were 1 do I go through and do the actual code here. Otherwise, if I ever hit a false in an AND, then I can just jump around the code and directly to the end. Now this makes maybe more sense to try to just do it with this rather than trying to do 3 at a time, because if you can do 2, you can also do 3, because it's the same as putting that in brackets, right? And this is a lot easier when you leave a 0 or 1 on top of the stack. I don't know how to erase. Is there anything code generation wise that you would like to talk about, or that you would like me to talk about? C invocation. I don't know why people are always so scared of that one. So you might as well do C invocation, or might as well do code generation for all invocations. And then I want to talk about field initializations afterwards to remind me. What are my invocations? Well, I have method invocations, which is something like O.f of E1, E2, dot, 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 En. I have explicit constructor invocations, which are like this, E1, dot, 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 En, or super, E1, dot, 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 En. And I have implicit constructor invocation, which is a new, let's call it an A, E1, dot, 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 En. Okay. Oh, we can't see. Well, ain't that too bad. Where'd they go? There you go. Is that better? Well, if you type something in the chat that says you can't see, and you can see me frantically typing or scribbling away, chances are that I don't know that. So the best thing you can do is just unmute yourself and say, you covered your iPad, or we can't see, or help, or whatever you need to say. Because I can't type and look and keep an eye on you. Can you see it now? Can you see me now? Can you hear me now? Yes, all right, cool. So those are the 3 kinds of invocations we have, and they're basically all, the same in some way. For a new, for example, well, actually, let's do them in order. So let's do number 1, right? Now, what are the invoke instructions that I can use? Well, I can use invoke virtual. I can use invoke static, and I can use invoke interface. When do I use the various ones? So this is if f is non-static and O is not of interface type. And of course, I'm talking about those. When do I use invoke static? If f is static, done. If f is non-static and O is of interface type. So it's always good to figure out which invoke instruction that we need to do first. So once we figured out what invoke instruction we need, then we can say, right, what is the code layout going to look like? You know what? Let's do it this way instead. Right. So what happens at the very end down here? Well, it depends. Should we call that one here for A? Well, maybe not like that. A, B, and C. So let's do code layout for A first, and then we'll do B, and then we'll do C. Well, that one is going to be an invoke virtual. Right. What's the first thing we need? Well, it's a reference, right? We need code for O. And I'm just going to put a little asterisk on there and then say here, if no target then use this, i.e. A load 0, right? It's a non-static method. It's called, if it doesn't have a target, then it's called from a non-static context. And there is a this. We already checked that in the modified checker. So we can say code for O or A load 0. Now, what is this then that I have here? That's going to be code for E1, E2 dot 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 En, right? So code for E1. Now, just like we had problems here, that was an integer, but I was going to do dadd, so I got to convert that. I might have the same problem here, because it could very well be that that's an integer in the invocation, but on the target method, it's a double. So we might need some stuff here. So again, it's just going to be a gen data convert between what? Well, the invocations. Let me just check that it's called arc. I can't remember. Let's see. It's called params. Good thing we looked in. So that's the first child. I think this needs to be cast. This probably needs to be cast to an expression, but you can figure that out. And what? Well, if we just flip back to here, we can see that there is a target method. Cool. So we can say in dot target method dot. Well, let's just look in method declaration. And they are called params there as well. So that will data convert if it's necessary. Then we have code for E2. Then we have data convert code. And that's the same here, just with child 1 and child 1. Dot, dot, dot. So at this point, my stack will have a reference E1, E2, dot, 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 up to En. And of course, the invoke virtual requires the reference and the parameters in the right, converted to the right type, which these data converts take care of. Right. Now we need to do B, which is the invoke static. And remember, it was O.fe1 dot 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 en. So if we think about this again, what are we going to do at the very end down here? Oops. We are definitely going to use. Did I do that in? Yeah. We're going to use invoke static. What is going to be on the stack by the time I get to here? We can sort of do that in reverse order now, which might actually make sense to think about it, because I don't need a reference, right? I just need E1 dot 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 En. There we go. Now, this block is code for O if O is not a class name. Remember, we just talked about how that target needs to be evaluated, even if we're just going to throw it away, because we're going to do that. Pop. So this is only done if O is not a class name. Okay, so now we're going to have code for E1, some data convert code, code for E2, and so on. So exactly, at least that part of it is exactly the same as we had here. What was C? Oh, I'm going to do that one here. C. Just like A, just with invoke, interface. That was number one. So that was just the regular methods. Now we have explicit constructor invocation. We'll grab that. We'll copy that and go here. Right, so there's a this call and there's a super call. We need to start with, so let's see, how do we do that here? What instruction do we need? There's, oh, by the way, there's one caveat over here another one that I wanted to say. There's actually a D here, which is invoke. Invoke special. And that's if O is super or the method is private. It's sort of a strange corner case, and if you were to invoke those if you were to use invoke virtual, it would be fine for the private one. That wouldn't be a big problem, but it could be a problem with the super one, because if you had an invoke virtual on a super, then things could go strange. Let's actually just try that real quick. So I think I'm just going to put in class A void F system without the print line A, and then we'll say class B extends A, and we'll do one of these guys as well. There we go. And then we shall put something in here. Should we just say public static void? Actually, static void main string args. But we need something else. We need a non-static method called void G. There we go. And this is going to say B equals new B dot G. And in here I'm going to say super dot F. Right. What's that going to print when I do this the right way? So what's the output going to be of that code? Think about that while I compile. All right, any last takers? Any first takers? What's the output going to be? Now, of course, you probably want to see it again, don't you? Yeah, nobody? How many are we today? Wow, 27. New low. ABBA, ABBA? Shane says A, Alexis says B, Baron says A, Xavier says B question mark. So I guess that's a leaning towards B, and Chili says A. If only you were a Swede. I don't know. Why would you want to be Swedish? Bork, bork. Danish is so much better. Right, so if we think about it, what is... this is awfully confusing. You know, I will give you that, because what's the difference between super and this? So let's just try something else. If super equals this system.out.println super is, well, I guess we should say this is super. What? Am I not allowed to do that? That can't be right. Why can't I do that? Let's see if I can do it in Java. No. All right. So cool. I can't do that. But it is true that super is actually this, because if you have an invocation of this type here, what is the value that you are going to produce for super? Well, it's an A load 0. Well, what is that address 0 in a non-static method? This. So super is this, and this is super. And everything is awesome. So if this is super, I mean, I suppose we could do this dot f, right? Now, would it make any sense if these two produce the same thing? No, probably not, because this dot f, well, it's clearly that one, and it doesn't make any sense that super.f would be this one as well. It ought to be that one, right? But if the value you load on the stack for super is the same as the value that I load on the stack for this, then there's got to be something else that differentiates these. So let's try to run that and just see if if the reference compiler is broken. Oh, it says AB. That's exactly what we expected, right? Right. So let's actually just look at those two things here. What do we expect the code is going to look like? Well, this one here, we expect that this is going to generate code that says a load 0 invoke virtual b f nothing void. This one is going to say a load 0 invoke something a f v, like that. Now, what would happen if I said invoke virtual there? Well, let's just see. A load 0 invoke special. Where's the other one? Here. A load 0 invoke virtual. Okay, I'm just going to change this one here to invoke virtual. And look, I'm leaving that A there, and that one is a B. So we'll save that. We will re-Jasmine B, and we'll rerun both. And what am I going to get out of it? B and B. Right, because whatever class is here is of no importance for the invoke virtual. The invoke virtual will inspect the reference on top of the stack. And since that is a load 0 in both situations, which is this, it'll say, right, you have a B. Oh, B has an F. I'm going to call that one. Whereas if you say invoke special, that says, hey, don't look for an implementation of F in the class that this is really of, but try looking in this class instead. I mean, if I'd done that and I said a B there, what would have happened? Well, we'd probably get exactly the same as we got with the invoke virtual, which is BB. But if I change it to an A and run it now, then of course it does exactly what it's supposed to do. So this one here is an invoke special. So that's why the super has to use invoke special. Otherwise, there's no point in having the super. Well, at least not if super is equal to this. Now, just to see that I'm not full of gunk, if I said void h, and I said private that, and then we say H there. Let's just see what comes out. Invoke special. So the reason for that is that private methods can't be inherited, and it's faster to do an invoke special than it is to do an invoke virtual. But so actually, what's really interesting here is, would it work if I did that? So let's just make sure that it prints what we think it does. And it says, haha, H right there. Cool. Now, what would happen if I made that one virtual? Nothing. It will work just the same. It just runs a little slower. Right, so those were just those two caveats. So back to this one here. Which instruction are we going to use for the invoke here? We're going to use invoke special. And invoke special, the class name in the instruction matters, as opposed to in invoke. I'm not sure that's good English, but it'll have to do. Right, so what do we got? Let's call that one number 1, that one number 2. Number 1 is there. Switch back to blue, we'll make some lines. Right, this invocation surely is an A load 0, and it ends in a invoke special. Let's say that we have a class hierarchy A, B. Then for this one, let's just say it's B init whatever void. What do we have in here? Well, we have code for E1, data convert, code for E2, data convert, ... Cool. What about number 2? That's the only difference, right? Because it is in the superclass we're invoking the method in instead. So the explicit constructor invocation is no different than this sort of stuff, except for we always use invoke special, and if it's a this call, then the class that goes here is current class, and if it's a super call, the class that goes there is the super class of current class. They always load their target as a load 0 because this and super are the same, and that is just exactly the same that we always do. So the target, I think it's called constructor or target constructor or something in the C invocation. So if you can do a C invocation, you can do a method invocation. If you can do a method invocation, you can do a C invocation. And if you can do a C invocation, then you can do a new, because they are exactly the same. So let's just do that one and get that out of the way. And then I want to just if we don't get to, no, we'll talk about, probably won't get, we'll see. If we get to it, we get to it. If not, then we'll talk about fields next time. Oh, come on now. There we go. So an implicit, right, what are we going to do? It's going to be an invocation of a constructor. Constructors are always special. And it's super easy, right? Because it's always that class, and there are the arguments. So it's I mean, it can't be much more straightforward when you've done the other ones and understood how they work. So down here we're going to end with invoke special a init blah 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 v. Cool. We're going to probably have something here that says new a, and then we're going to duplicate that because I need a reference for the invocation and I need to leave a reference for a as well. Code for E1. Data convert. Code for E2. Data convert. Dot dot dot. So, did that clear that up? I think it probably did, didn't it? Maybe the person who asked left. Actually, let me show you something else. I am going to have a static int I, which is equal to 0. And then I'm going to have int aj equals I plus plus. And do that. And then I'm going to ask you, what is the output of this program? You're lucky this isn't a job interview. This is the kind of stuff they ask you. 2. Any lower? Why? Where did 2 come from? A flashback from office hours yesterday, right? So you should get it right, shouldn't you? So you get 2 if you implement your compiler incorrectly. So Ilya, if you get 2 in your compiler, back to the drawing board. 3. No, not 3. Stop it. So let's try. Espresso C. I'm gonna come after you. I know where you live. Espresso C x8 Java. Jasmine A dot RJ. They didn't ask at the McDonald's interview. No, they probably asked you if you could fix their soft serve machine, didn't they? Espresso A, and we get a 1. Now, why am I asking about this? Well, it's because look at this stuff here, right? This is stuff that has a side effect. So when we deal with things that have side effects, we got to be a little careful, right? Now, this is code, right? There's some code that needs to run. This is got to be something like iload 1, iconst 1, iadd, istore, or it's going to be an iinc or something like that, right? And the question is, where on earth does this run? Well, it's code that can't just sort of hang around here. So there are 3 places code can run. It can run in a method, It can run in a constructor. So here's a method. Here's some constructors. Or it could run in a static. Actually, remind me to talk about auto-generated static initializers next time. Somebody asked me. We don't have time to do it today. But it could also run here. Now the question is, where does that run? Well, let's see. It's an initialization of a non-static field. When should that happen? Well, it should happen when the object is created. Cool. So would it be fair to say that if I take this initialization, like that, and I plunk it here, and I plunk it there, and then I just say no value there, because now I don't have code floating around. Now all my code is nicely entrenched where it's supposed to be, or encased. Right. So is that correct? Let's try. Now we get a 2. Exactly what Ilya said earlier. Why do I get a 2 now and not a 1 like I did before? What did I do wrong? Well, if I got a 2 printed out here, it's because I must have been incremented twice. Well, there's an incrementation here and there's an incrementation here. And look, which constructor do I call here? I call this one. What does that do? Well, it calls explicitly this one, which calls explicitly the one in the superclass, which does nothing, comes back here and increments I. And we can basically see this. We can try to put in. So if we say from A, I is equal to plus I. And actually, if we do this, we can see if these are really called twice. See, they did get called twice. Okay. That's not good, right? I mean, it's probably not a good idea to initialize fields with. Well, this might make sense because maybe this is an instance number and this is an instance counter. So this might actually be code that you could very well write. So how do I avoid this sort of nonsense? Well, it's fairly easy actually. If I have a this constructor call, then I know somebody else is going to take care of initializing my fields for me. So I can just simply say, I'm not going to do it. Because if you think about it, if you call a constructor that has a this call, then it's going to call another constructor in the same class that's going to do the initialization of the fields for you. Unless it's a this call, which is then it's going to call somebody who's going to do the initialization for you. At some point, they're going to have to hit a constructor that calls out with a super call. Otherwise, we're going to have circular constructor calls, and that won't work. That's not going to be good because that'll crash the VM anyways. So if the rule is very simple, the rule is very simple. If you have a this call as an explicit constructor invocation, don't generate field inits. Now, how do you generate those field inits? Remember, you have this visitor here. It's called generate field inits. It implements just one method, which is visit field deco. If you create an instance of this one and set it loose on the current class, it'll run through the current class, find all the initializations that you need, and you can see what it says. It says if it's static and we're generating fields, or generating for static fields, that's if that last one here is true, then go and do this stuff. Otherwise, if it's not static and we're not generating for static fields, like the other option, we do that. And if you look at this particular line here, I want you to look at this and understand it. What does that say? Well, it says, is there an initializer? Is a modifier not final, or is it a final modifier, but with an initializer that is not a constant, i.e. a literal? In that case, code needs generating. So if I were to say something like current class dot visit new generate field inits blah 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 blah, comma true. If I did that, in Visit Constructor Decal, immediately after having dealt with the C invocation, then I would get code injected into my code for the constructor declaration that would do all the field initialization for non-static fields for me. Now, of course, I should only try to do that if it's not a super call. Sorry, if it is a super call. If it's a this call, then we just skip it. Similarly, in the static initializer, the first thing you should do is do exactly this, just with a false here, and this thing here will go and find all the fields that are that should be initialized and that are static, and generate the code for it. So remember to ask me about auto-generating static initializers next time, because what happens, this is a complete cliffhanger, I mean, and you're going to have to wait until next week. I don't know how you're going to make it through your weekend, but somehow you're going to have to deal with it. What happens if you have static fields that are initialized to something that is not a simple constant, but there is no static initializer? What happens? Where does that code go? And on that note, have a good weekend, and I'll see some of you tomorrow.
Professor Peterson, you have to ask a quick question real quick.
Sure.
I noticed like during the code generation, like for like if statements and stuff like that.
Hold on a second. I'm just gonna rebut here. Rude, yes, but funny. So now you can think about that all weekend. Neener.
One of my one of my questions is that like